Hey, what's up guys, my name is Jono and welcome to the 7th episode of my Flappy Bird series. Today we'll put everything we've done so far into practice by drawing an object. So what kind of code do we need to draw a triangle in OpenGL 3+? We'll need three basic things to accomplish our simple goal: a vertex array, a projection matrix, and a shader program. In fact, we can even drop the projection matrix. Let's start with the vertex array. So what are vertex arrays in OpenGL? A vertex array is basically an object that stores an array of vertices. Vertex arrays can also store other data, such as normals, colors, texture coordinates, or literally any data you provide it with. At the bare minimum, we need vertices to render objects in OpenGL. Let's hop into our main class and import GL30. We'll also go ahead and import GL20 since we need that for shaders. To create a new vertex array object, we simply type GL vertex arrays, and assign the ID we get to an int. I've called the int VAO, which stands for vertex array object. As you saw with textures last episode, we need to bind the object before we can use it, so let's bind our vertex array. Now that we've effectively selected our vertex array object, we can render it by calling GLDrawArrays, with the mode set to GL triangles, the first vertex being index 0, and the amount we want to draw being 3, since 3 vertices make up one triangle. That's it. Now if we run our game, you'll see absolutely nothing. What our code has essentially done is create a new vertex array object, and then render it by sending its data to the graphics card. The graphics card has no clue what to do with the data it gets though, so our next step is to program the graphics card and tell it what to do with the data it receives. So how can we program the graphics processing unit, or GPU? By using shaders, that's how. Shaders are a fantastic addition to OpenGL that allow us to run code on the GPU, and since the graphics card is optimized to run many of the graphics related algorithms we want to implement, it's insanely fast. So let's go ahead and set up the two shaders we need. Let's right click our project and create a new folder called shaders. This will contain all the shaders we'll use for our game. Now let's right click our shaders folder, choose new and file to create a new empty file. I'm going to call it shader.vert, with the vert standing for vertex shader. It honestly doesn't matter what name or extension you give the file, since we'll be reading its text. I'll also make a new file called shader.frag, which will be our fragment shader. Let's open our vertex shader, since that's the first shader that we'll run. The vertex shader will be run for each vertex, so in this case 3 times per render call. Our mission is simple: position these vertices. Up the top we'll put hash version 330 core, which will use the core profile of GLSL version 3.3, which matches up nicely with our OpenGL 3.3 version. Core will not let us use any of the deprecated code from previous OpenGL shading language, or GLSL, versions. Like any program, there needs to be a main method to define the entry point of the program. To create it, we simply create a void method called main. Now we're not actually sending any real vertex data from the CPU to the GPU. In fact, the only thing we're sending is that we want to render triangles and 3 vertices. That's it. That vertex data does need to exist, so let's just create it in our vertex shader. We'll make a constant vec2 array which will hold 3 2-component vectors, one for each vertex. Since we haven't specified any kind of projection matrix, the bounds of our screen horizontally are -1 to 1, left to right, and vertically -1 to 1, bottom to top, and near to far is also -1 to 1. So let's create 3 vertices that lie somewhere within those bounds. I'll create one at 0.5, -0.5, one at -0.5, -0.5, and one at 0.0, 0.5. There we have it, 3 2D vertices. Now we can output them for rendering by setting GL position to that array, with the index we want to render being GL vertex ID. Vertex ID will be either 0, 1, or 2, because when we call GLDrawArrays we specified the count to be 3. That's basically it. The only problem is that GL position wants a 4-component vector, not the 2-component one we specified. So let's convert our vertices vector into a vec4 by passing it into vec4's constructor, and adding the 2 additional components we need. For Z I'll put 0.5 and we'll leave W as 1.0. That's it. Our vertex shader is complete. Inside our fragment shader I'll set the same version and create the same main method. Fragment shaders run per fragment, or basically per pixel. Our job here is to set the color of each pixel that makes up our triangle. Firstly we'll need to actually output a color, so I'll type out vec4 color outside the main method. Each component of this vector holds one channel of color from 0.0 to 1.0, with the channels being RGBA. Inside our main method, let's set this color to be a nice blue by specifying 0.2, 0.3, and 0.8 as the RGB values, and we'll leave the alpha as 1.0 to make our triangle fully opaque. That's all the shader code we'll need to type. Back in main.java, we need to load and activate this shader. Let's load it by calling shaderutils.load, with the file paths of our two shaders, and assigning the result to an integer. To enable it, we simply need to call GLUseProgram with the ID of our shader. Now our shader is enabled, and we're drawing our vertex array. Let's launch our game. Look at that, a blue triangle. Mission accomplished. Thanks for watching, and I hope you guys enjoyed this video. As always, a like is greatly appreciated. Next episode, we'll be creating a class for handling the shaders in our game and setting up our projection matrix. Goodbye.